Morty, we've got to turn the project in early.
Hey everyone, how are we doing? Good to see you here, Cameron and William and Sarah and Jennifer. How is everyone doing? Do you hear the music? You hear the music. Couldn't hear the intros though. Had a little breakfast real quick. Sorry about the 5-minute late start right here. Let's jump into some questions. What shall we do? Doing good. Good to hear. Let's start with some 10,000 points. I know the points have gotten crazy, but points crazy. Good to see you, Catherine. Really good morning this morning. Glad exam grades are finally in. Well, I have a secret. We are getting points on the exam. I could make a video here while we're doing it, like, well, I need to go into After Effects and I didn't have time. Parents' visit was great. Thank you, Sarah, for asking. It went really, really well. We had a really great time, showed them around campus. They enjoyed it, and they were like, we had a great time. They can't wait to come back for Christmas. So this was our Thanksgiving. We had a really good Thanksgiving. Shouts to my wife who cooked pretty much all day Sunday, and I helped some, but she did a ton of the work. Like I helped a little bit. So really big, huge thanks to Chelsea. Just so much food. Good times, good times. With that, what should we do? Should we do conference journals for the mean? Did Brian edit a video while we're doing this? Thank you. Yeah, good times. What do we want? What shall we do? Is Vol for Life Day. Time to be Georgia this week. Thank you to everyone. We've been doing pretty good on grades. Data analytics number 7. Sure, let's do that. You got it. Data analytics number 7. Number 7. Thank you, Catherine, for asking. And there is the visualization playlist, the Chapter 14 quiz, advertising campaign, please. Ooh, we'll do that next. You got it. Talk a little bit about data analytics number 7. 5 people have already submitted, or 7 have already submitted. I graded a few. There's the visualization playlist if you want. Great job right there, Sarah, with all those points. So let's pin this message from Ubot. And I'm gonna go over here to the data analytics, talk a little bit about it and how to do it. Okay, let's over to the main screen. Okay, this is data analytics number 7 right here as I quickly take the bookmark on it. We are at 503, Stat 201, data analytics. Number 7, the last one. With this, and Sarah, crazy points, love it. So using the JMP software, download this bike data set right here. We're just gonna download it. We're gonna click open. JMP's gonna open it. So JMP's gonna say, do you wanna open this? And we say, yep, there's the data set we're gonna be working with. We'll work with it here in a moment. This is the utilization of bikes right here. We're gonna take a random sample to start, 200 plus the last 2 of our UTIDs. So if my last 2 of my UTID is 23, then I'd enter in 223. Need to put this at the start, and one thing to always look at is the rubric. Look at the rubric on how you're graded to see where you will get points. I'm gonna go over some kind of ideas in general right now, but how can you know, has anyone been getting a lot of 10 out of 10s or 9.5s or very close to 10 out of 10s on these and following the rubric? That's always my advice, is like, look at the rubric when you're doing it and be like, did I do this? What button would I click here? Great job, Cameron. So look at the rubric and be like, would the grader click the top button with this? Like the first thing is, per the instructions, your name, your instructor name, your section number, your class, your time are all included at the top of the document. Did you do that? If you did it, you're gonna get those points. If you don't, then you won't. Next thing was a random sample taken. So easy points right here. Put your information at the top, take your random sample, good to go. Now you have the correct analysis and output is provided. So when you gotta do the correct analysis, conditions are listed. A condition is named, thoroughly explain why it is met or not met. So if you don't do a thorough job explaining, you get a half point. Conference interval interpretation, know how to interpret the 4 generic parts. We'll go over that. Conference interval correct analysis is given, and then this is for the mean, the 4 generic parts, and well, the interval and the write-up. Write-up is accurate, and written complete sentences in paragraph format. So you should get full points there. If you feel like they're mean and take off a point here, let me know. But very important that you know how to do these things. So let's go over to the bike data. And what we're going to do. And do check out the visualization playlist where I go into a lot of depth on this. I'm not going to do the same data set because I never want to do your data set. So let me go. I'm going to grab a different data set. I'm going to grab the, let's see here. We have a JMP data set. JMP, installing and downloading JMP. Apple Store data. I'm going to use the Apple Store data right here because I don't want to use your data set. Okay. So this right here is file size, and this is category right here. This is a different data set. Brian is using your data set or a different one to show examples right now. Is Brian using your data that you will use for this assignment or a different data set? What am I using? Your data that you will be using or a different data set to show examples? What am I using? Different. Sarah, thank you so much right there. We'll throw some points. Just want everyone to know that and acknowledge that because I have people sometimes watch the videos on mute, I think. And so you writing that in the chat might let them know you're not using this data set. So I did what Brian did. Well, Brian does different things. So we go right here and we talk about what we want to do for this assignment. So once again, I'm covering everything, but I'm also explaining kind of what you're learning and why. So think of this, if you already know how to do the visualization, as an explanation of what are we doing. So we have here a sample of Apple Store apps. There's 2,250. You think there's more than 2,250 apps in the App Store? What do you think? There's more or there's exactly 2,250? We're actually going to go and take a subset from this. So we're going to do the assignment a little bit here. And the subset under tables subset, we're going to go here and go 223. Make sure to do the last 2 digits of your UTID. Click OK, and there's your subset. Make sure it has the right amount of rows. I would say there's definitely more. Thank you, William, right there. We're just going to go keep giving points for all these answers. So I'd say there's definitely more than 2,250. Now we have a subset of it, so we've got a unique random sample right here. So with this, I only have one quantitative variable to analyze. Let's do the proportion first, because that's the first one you do, is proportions, and it's the first interval we learn. So we're going to go here to analyze distribution. These are the key things you need to do to create the jump output. Analyze distribution after you have your random sample. With analyze distribution, you're going to click it, and then take your categorical variable that you're supposed to use. I'm just going to use category right now for mine. Make sure to follow the instructions of the variable to use. I'm using category right here. I think you're using rain, no rain. And we're going to click OK. So I'm clicking. I can just disappear if I want. We're clicking analyze distribution, and then the y variable is categorical, and you know that because it's red. And make sure to use the one the assignment tells you to use right there. So now here is the output. My output's a little bit longer than yours. And we might also have a problem for mine. Dun, dun, dun. Now, this is not a 2-level categorical variable, but we can still do proportions by going here and going to the red arrow here and go to confidence interval. If you want to do something other than 95, 99, or 90 in the reverse order, you can go to other and enter in other. I'm just going to do your classic 95, but you might want to click other. If it says make like a 99.5 or a 99.8, whatever you want to make sure to click other if it is not listed here as a % confidence that we can use by default. I'm going to click 95 because that's classic, and look at what we get. We get more output. Hey, more output. With this right here, what does this mean? Well, first off, I want us to think over the success-failure condition. When you do the success-failure condition, you're supposed to have at least how many successes and at least how many failures, which is the third condition for proportions. Random sample was taken, 10%, less than 10% of all the data, and then of the population. And then last but not least, for proportions, after we pause, we say we're doing success-failure. We want at least 10 successes, at least 10 failures. And so when you look at book only has 1 success. And this is p hat right here. Prob is p hat in the output. You could even check the work. Like if you don't believe me, because the equation is np hat is greater than or equal to 10. Well, this is p hat right here, 0.0048448 times 223, and that'll be 1. Or if we had more decimals, it'd be 1. So all these right here, like at the 17, if we take 0.07632, which is p hat for that one, if we talk about it, it'd be the sample proportion of people or education apps on the App Store. Then we go right here and times it by 223, which is n, the sample size, np hat, and we get x right there, which is 17. So we do have issues on this one. So technically the count right here is x, and you'll have only one others, which is n minus x. It'll add up to n total for you because you only have 2 groups. So this does not pass, mine does not pass the third condition because we don't have at least 10 successes, at least 10 failures, and you should quote the what when telling people these things. You should always give the what backing. You should, like I was talking about these things like 1 and 17, which 1 is too small, 17 meets it, but the other ones don't meet it. Give the what, starts with an N. Give the what backing, give the what to people. When you're explaining things and you're saying we need at least 10, you should give the whats. Quote the whats. Make it the numbers. Give the numbers. Say like, oh, there was only one for this group, so we don't have at least 10 successes, at least 10 failures. You could say also, mathematically speaking, p hat is the sample proportion, which is 0.000448. We multiply this by 223, and that also gives 1, which is x, which is the amount of successes, which is less than 10. So we failed the condition easily with book apps right there, not having at least 10 successes, at least 10 failures. So what does this mean if we could interpret it? The problem with failing the conditions is your interval is not properly calculated, so interpreting it is kind of a not so great idea. You should pass for yours, hints. And if we were to interpret this, we need to think about what the interval means. So let's look at this interval right, I can't select just one. What does the interval for entertainment mean? So let's write out our interpretation here. So people know what to write. We're going to open our billion Word documents. Oh, they're opening up on the other page. Okay. Oh, do we still have one open with the IM? Oh, man. Should have left open the IM. IM, blank percent confident that the true blank is contained in the interval blank to blank. Oh, wait, I think we just had it. Here it is. Here's the worksheet we made a little while ago. And so with this worksheet, get back over to my thing over here. I am blank percent confident that the true blank is contained in the interval blank to blank. So can you interpret, and you need either say true proportion, true mean, or true difference in means. One thing we're missing right here is you need the context afterwards. So take a moment, and this is like the test. Can you interpret this one here for entertainment? Who can do it in the chat? If you can do this now, you have to think, am I analyzing categorical, which we are, that'd be proportions. When you're analyzing means, that would be quantitative data, which this is not, because this is not, the question is, what category is this app in? It's not a quantitative question, like how big is the app? That's quantitative, which we'll do next. So interpret this interval right here for entertainment. I wish I could select it and show it. I can't click on it. Entertainment interval, which goes from the lower to the upper. That's two of the parts. The other parts would be the 95% confidence, and the other part would also be the middle part, which is the context of it. Who's got it? This is the practice right here. If you're watching this in the future and you can't do this, you've got to practice. So you have to say, I am blank percent confident that the true blank is contained in the interval blank to blank. So what would it be? I am blank percent confident that the true blank proportion, because it's categorical. This is where you insert your confidence level. I am 95% confident. That's mine. That the true proportion of entertainment apps. Sure, close enough. Entertainment apps. The true proportion of entertainment apps in the App Store is somewhere between 6% to, I think it was 14. I'm just rounding those numbers for time being, but does that make sense? I am 95% confident. If I look at it, I can actually say it. I am 95% confident that the true proportion of entertainment apps is somewhere between 6.2% to 13 point, or that's 14 when you round it, so 6 to 14%. Or you could do decimals 0.062 or to 0.13966. I am 95% confident the true proportion of entertainment apps in the App Store is contained in the interval. Boom, right there. Exactly. That's like, what is the true, like what amount of apps, what proportion of apps are really entertainment? Well, somewhere between 6.2 to 14%. And William right there earning us another 10,000 points. Keep up those answers, William. Great practice. Even practicing it out right there is the way to go. So good work, William, right there. So that's how we do confidence intervals for the proportion. Make sure to have this output in your assignment. Good stuff right there. Now we do confidence intervals for the mean with the same steps. Analyze distribution. Analyze distribution. And we're just going to pick the quantitative variable. Notice how it's blue right there. Blue for quantitative. I'm blue. Ba-da-dee-da-da-da. Then put it over there. And then click OK. We get the following, not 2 hours later, we get the following output. We're going to click the top red arrow and click stack to put it in horizontal layout. We could add a count axis. Does it say add a count axis? If you want, add them. If it says add count axes, add count axes. That's where you do it. Histogram options under the second red arrow, count axis. And then you can expand it to make it look all pretty. You can even go over here and go to histogram options and go to color. Where is histogram display options? I thought histogram color was here. There it is, histogram color. I missed it. And we go a nice light purple. There we go. So with this right here, we now have a histogram showing us a right-skewed data set. Now, good for me, my sample size is 223. So even though the distribution is heavily skewed, we can now say that we have something that's nearly normal for the mean. This is the nearly normal condition via large enough n. Large enough n states that we look at the shape of our distribution. My distribution is heavily skewed. Yours probably won't be. And if it's heavily skewed, you need at least, I think since other people are watching this, I think the notes say like 60. I say 100, and I'm lagging right now. There we go, it fixed itself. NDI cameras are weird. But my sample size is way bigger. The assignment did say count access. Thank you so much, Sarah, right there. 10,000 points. Please make sure to add a count access. So also read over the assignment, see what the assignment says, because I'm kind of talking generalities here. I think it's the only, I was like, this alarm went off in my head, like, pew, 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 add a count access. Don't want people losing points because they didn't throw in a count access. Just gives it more context. But now we could add a specific confidence interval if we want. And the specific confidence interval can be added by going here to the red arrow, go to confidence interval, and you have the same options where you can do 90, 95, 99, or other. So if you click other, you can enter in whatever you want, like an 82% confidence interval. And we're trying to figure out the true file size of an app on the App Store. So here's the interval right here. The estimate is the center of the interval. The upper is the top estimate, and lower is the lower estimate. And can anyone tell me the margin of error pretty quickly for this interval? Don't worry about the decimals. Just give me a rounded margin of error. Give me a rounded, just round it nice and neat. Questions on the test sometimes say, what is the margin of error for this interval? You could get an interval like this. So the interval for the mean, to estimate the true mean file size of apps on the App Store. The true mean file size. What is the margin of error? Don't worry about decimals. Just be like, round it to one thing. Be like, it's about 10, it's about 12, it's about 24, it's about 30. What is it? The margin of error of this interval is about what? About what? This is a good test question. If you can do this, you understand margins of error pretty quickly. The margin of error is half the length of the interval. The interval goes from 127 to 176. But also margin of error, the center of the interval is 152. The top of the interval is 176. When you have a margin of error, you go from the center, 152, up to 176. You go from 152 to down to about 128. So the margin of error is very close to what? Like, it's about this. You can find out on a calculator more exactly. But margin of error is half the length of the interval. Try working this out if you're watching this later. To be like, oh, margin of error is half the length of the interval. Because there are questions on my Pearson that do this too. So if you have margin of error is half the length of the interval, anyone know the answer in the chat? I'll wait a moment, wander on the chat. So here's the way you can do it in your head if you're wondering how you can do it in your head. It's half the length of the interval, which is the distance between the estimate and the upper. Oh, I am not reversed image. So the estimate to the upper is 152 to 176. Like, that's half the length from the center, which is the estimate, 152, to the upper, which is 176. So 152 to 176. So what's the margin of error? As you go, so what is the margin of error? Does anyone know? Got W's in the chat. Margin of error is very close to what? You could do upper minus lower divided by 2. Not 12, it's 24. It's 24. Half the length. Good. Catherine, 130, some points right there. I could write this out. Let me try this for you. Ready? If a steak dinner costs somewhere from between $30 to $50, what is the margin of error? Good to see you, Evan. If a steak dinner costs, and great job, Sarah. If a steak dinner costs between $30 to $50, what is the margin of error? So the margin of error from 30 to 50 is what? The margin of error, be careful, not length of interval, but margin of error. 30 to 50 has a margin of error of what? Not the length of the interval, 10. And the interval could be written as what plus or minus what? Because then the center plus or minus the margin of error. So 30 to 50 could be rewritten as an interval, the center plus or minus what? Because the center is the estimate. So you could rewrite 30 to 50 as what plus or minus what? Because the center, you can just average the two values and get the center. So it just helps you better understand. And when you get to the test, and it's like, what's the margin of error? You're like, oh, it's half the length of the interval, or from the estimate to the upper, or the estimate to the lower. 24 the previous one, you got it. So the state question, 30 to 50, could be re-expressed 40 plus or minus 10. Does that make sense? 30 to 50 is 40 plus or minus. Great job, Sarah right there. And just understanding that and knowing that that's the 40 of the example I just did. That's the estimate, the center, like I guess the stake will cost $40 plus or minus 10. And then the 24 is the plus or minus that creates the 178 and the 128. Because you could literally go here and take this and go 152. We're on the wrong screen. Oh, I'm on that screen. There we go. Where am I? Great job. Good answers in the chat. So you go 152 plus this. Wait, 152 plus 24. 152 minus 24. There we go. So the center plus or minus the margin of error. And so how would we interpret this interval? I am 95% confident. The true what? I am 95% confident. We're trying to estimate file size. I am not 95. I am 82% confident. I am 82% confident. The true mean file size. Exactly, Hammer right there. Great job. I am 82% confident because that's the 1 minus alpha right there. I am 82% confident that the true mean file size is contained in the interval 127.8 megabytes to 176.3 megabytes. Good work right there. Does that answer the questions? And we did a little bit of a review of confidence intervals for the sample mean right there and confidence intervals for the true proportion right there. Confidence intervals for the true mean and confidence intervals for the true proportion. We have another question. Should have pinned it. The next question is about, where was it? I got to pull it up here. Where is it? Data 7, chapter 14 quiz for advertising. Yes, let's go check it out. Chapter 14, a little chill music right here while we get started. Advertising. I hear people use this on YouTube. Did I already... I gotta fix that button. Sad music. Confidence roll for sample means quiz. How's everyone doing? We're almost to Thanksgiving. Just 2 more classes. 90% confidence with 25 degrees of freedom. No, wait a minute. Wait a minute. There we go. 71. There we go. Got that one done. Nice and easy. Just put in the numbers. Works. Okay. Where is it? Where is it? Gotta figure out these. Degrees of freedom 3. That's virtually impossible to get. Degrees of freedom 3. That's ridiculous. Yeah, that first one I had impossible guess. Oh, that's awesome. Oh, that's really good to hear. It's really good. I'm glad. Go home and see parents, or come see you, either which way. Trying to find that question. It was advertising campaign. This doesn't take too long to do. That's good stuff. That's good interpretation stuff. I love finding t-statistics. I don't know, I'm weird like that. I'm like, ooh, find the t-statistic. That one has too many decimals. We're almost there. That's not advertising campaign. I feared we wouldn't find it. Okay, let's mark this in the notes right here, advertising campaign. Now this one we are gonna use jump. So you need to have jump open to solve this one. This would be a question on the test like reading jump output. So you would need to know how to read jump output. So chapter 14 quiz. In 1998, the year I was born. An advertising campaign, the 1,000 chip challenge, claiming that every 18-ounce bag of their chips contained at least 1,000 chips. Dedicated statistician at the Air Force Academy, no kidding, put that in, purchased some random bags and counted the chips. Some of their data are given below, complete parts A through C. I wish they'd given just the full data set. That'd be a lot of fun. Just give the full data set right there. That would be a funner thing to do. Hey, Donna. Good to see you. Hope you're having a good morning. Do you know you talk about the project a little bit? Yeah, we could talk about the project. You got it. So let's go right here, copy this to the clipboard, copy, click the arrow on the right side. Definitely might do that next because unless there's another question, we'll do it next. We're gonna go here to File, New Data Table. We're inside a jump with File, New Data Table. Now, one thing you always wanna look at is if there's column names or not column names. So we'll go to Edit, and I think we're just pasting. Notice how there are no column names. That was Edit, Paste. Be careful if you pasted with column names, the top one will go into the top column and your answer will be wrong and I can't correct it because you didn't paste the data properly. So with this right here, make sure to paste without column names, just a normal paste this time because there is no column name. Column name is the name of the variable. This one doesn't have a name of the variable. I noticed it when we were copying it. There was no name at the top, so I didn't paste with column names. I just did a normal paste. So now right here, we're going to double click if you want. This is optional. We're going to say chips and just click enter. I double clicked. You don't have to do this. It just makes your data look more pretty. So now we have our data in JUMP, and we're going to go to Analyze Distribution, just like with the project or the data analytics. Analyze Distribution. We're going to double click the variable, chips, and put it into the Y columns. Make sure you have 14 observations. And with the 14 observations, put chips, the quantitative variable, it should be blue for quantitative, into the Y columns and click OK. And there is the distribution. We're going to click the top red arrow to stack it and make it easier to look at. I don't know why JUMP doesn't do that by default. And now we have it in horizontal layout right here, ready for us to analyze. And you can see a 95% confidence interval for the mean was made, along with the summary statistics with the quantiles, the 5-number summary, the min, the max, the median, all the values. There were 14 observations. The standard error, which is S over square root of n, is 25, and 95 is the standard deviation. Now, here's a fun thing, which is interesting to know. The margin of error is basically 2 times the standard error in a lot of instances. Not exactly, it's 2 times, or it's t related to the level of confidence. But this interval right here is close to plus or minus 51 because the standard error, S over square root of n, and the t is very close to 2-ish. T is probably about 2.1. If you wanted to find the exact t statistic, you would have to go to the apps. And here's a question which is really good for the test. How many degrees of freedom are there for this one sample t? So for this right here, how many degrees of freedom are there for this one sample t? For this question, how many degrees of freedom are there for the one sample t, which means we're doing one mean. That's what one sample t is. It's one mean. We're just analyzing one mean. When we say one sample t, we're analyzing one mean. You need the information behind my head. So how many degrees of freedom are there for the one sample t with 14 observations? There's 14 observations. So what are the degrees of freedom? JUMP will actually clue you in on this if you do a t-test, which we'll be doing this week or today, close to it. Do a t-test. 13, you got it. Test the mean. We don't want to use a z. And we'll test the mean to see if the mean is equal to, I'll tell you the p-value. Sure. The p-value on this one's going to be a little bit higher than 0.05 for the top one. And a little bit lower. Whoops. Whoops. Is that right? Yeah, it makes sense. Because it's outside the interval. Whoops, went the wrong way on it. But there's 13 degrees of freedom right here, and this is a t-test. When we do a one-sample t-test, we could find out the t-statistic used to make the interval. And the t-statistic used to make the interval would be, let's go over here to student t, click this, put in degrees of freedom 13. It is a t of negative 1.7, between t of 2.16, t of 2.16 for the 95% confidence interval and 13 degrees of freedom. So if you were to times 2.16 times the standard error, which is 25.41366, that's the margin of error. Take the margin of error and add it to the center, and you get the upper right there. It's more decimal accurate, but that is the upper value when I took the t-statistic. The t-statistic is kind of like the z, but you have to find the t-statistic based on the degrees of freedom. The degrees of freedom for a one sample t are n minus 1. There's the sample size. Minus 1 are degrees of freedom for the one sample t interval or one sample t test. Really good information right here, and we actually have all the information on the screen, I think, right now to complete this problem and more. We didn't need to do this test. We haven't gotten to that yet, but it also showed the degrees of freedom that we could check. So any questions about this? I basically did a lot of the theory right here, hoping to review, and you just have to hear these things a lot of times, and one day you're like, I hate that too. I want to talk to them and be like, why do you use capital N? Why? Like, look at this. Population size notation, sample size notation. I'll be darned, and look Google's saying right here, capital N refers to population size. Lowercase n refers to sample size. Lowercase n, if it's a sample, which it is, I'm assuming a lot of things I put in jump are samples. Maybe it just always assumes you have the population, but I'm making an interval, so, and you're using t-statistics, so you're assuming that's a sample size. I don't know. You're making me mad this morning. So let's go and finish off the question right here. But I do dislike that. That is one of my big qualms, is that I don't know why they don't just update it. Maybe it's like, I wonder if the person who entered it in just capitalized it and then they didn't realize it. It was capitalized. Same thing, and right? Nope. Check the assumptions right here. The assumptions are that it is random sample. Less than 10% of all chip bags out there, and also that is nearly normal. And they don't really mention that the nearly normal condition. I wish they did. They're going to do it down here next, I believe. And so one can assume that the data are independent. They're from random, so one can assume they are. No, we're talking about if the data is random, they'd be independent. That means that one bag of chips would not dictate what the other bags have. It's not because the 10% condition is met that they're independent. So check the independence, check the data for independence, yeah. Because it's random, so we say they're independent. Next, we see all of these range from 900 to 1600. So we look at the shape of our distribution. Now the thing is ours does not go from 900 to 1600. So you want to double click this axis right here and type in 900 to 1600 by double clicking the axis. Click OK, and now we need to go to units, and the units are 100. Don't want a minor tick, let's do that. And there we go. So once again, the settings on this should be 900, 1600, 100 with no minor tick. That adds in these extra little things right there, which create more bins. And by doing this right here, we can see the answer, which is the first one. I think we lucked out. It is the first one. So it also has a mode in the center. Yours might be different, but there's the data is also randomized, so you can't really tell by looking at it that way. Wish they just put it in order. That'd make it nicer. Okay, next we see here, evaluate the histogram. I mean, that histogram looks pretty darn what? That histogram looks pretty darn what? We only have a sample size of 14, but that histogram looks pretty darn what? Because we're checking the nearly normal condition right now. Symmetric, unimodal, like nothing crazy going on here. So looks pretty symmetric, looks pretty normal. So since it's mostly symmetric, mostly normal, we don't need a large sample size. A sample size of 14 is probably large enough. So we're checking the nearly normal condition by way of large enough. Since it's nearly, and this is the thing you do, 1, look at the shape. Looks pretty unimodal symmetric. 2, know the sample size associated with that. And it's probably like 10-ish. Like you don't need a large sample size because it's basically normal at this point. And so since it's basically normal, the distribution of the mean would be also more normal. And so the large enough n via central limit theorem. So many big words. So what does it say down here? The histogram is roughly unimodal and symmetric with no outliers. So one can assume that the data came from a population that follows the normal. Good deal right there. And this is where they always get me. We are using the t, but the condition is nearly normal. So if I get one wrong, it's going to be this one. The t is the distribution we are using. So, yeah, I mean, it has no outliers. We're going to use the t to make the interval, but we would assume the population is normally distributed, not t distributed. I don't hear that said, so they always get me with this one. Every time I do it, I'm like, did I get it the other way? But if you got that one wrong, you can always message me, I'll correct it. But you'll get to see the right answer here in a moment. So if we get one wrong, it's going to be that one. This is going to be the interval we created right here. The interval, the 95% confidence interval, is in the output right here, 1177.60 or 0.6. Put the lower first, 1177.6. Then go here, and the upper of the interval is 1287.4. What does the interval say about Nabisco? Now, this is on average. So on average, we would expect somewhere between. So I am 95% confident the true mean chips in a bag of Nabisco's Chips Ahoy is contained in the interval 1,177.6 to 12.87.4. That's an average, so it can be a decimal. It's not like you get a half a chip, which you could also get that. Based on the confidence interval is entirely above 1,000. This means the mean number of chips per bag is likely more than 1,000. However, the normal model, ooh, see, look at that. We're doing a normal model. or the normal model predicts that a small amount of individual bags will have fewer than 1,000. That is true, because it's not about, oh, cancel. Check answers, we did it. So everything's in line with that. And here's the thing, is if you use the standard deviation, and you go down 3 standard deviations, does it make sense that an individual bag, that's 3 standard deviations, there might be some bags that are what's that don't have 1,000 chips. There might be some bags that are what's that don't have 1,000 chips. Some bags that are what's that don't have 1,000 chips. Like more than 3 standard deviations below the mean. Some bags that are what's that don't have 1,000 chips. Outliers. Great job, Evan, right there. Some bags that are out. So individual bags might have less than 1,000 chips. But on average, which is the mean, we would expect on average each bag, or like the average of bags, to be above 1,000. So if you were to look at the truth is, yeah, on average there's at least 1,000, but an individual bag could have less than 1,000. So their claim seems kind of accurate, like 1,000 chips in every bag. Well, you're going to average that. Like if you got one that was like 980, the next one might have, what's our best guess of how many chips they have? Well, that'd be the mean. So you're probably going to get about 1,232 chips per bag. They need to do a 6 Sigma process. Find out more about that at 6 Sigma. But if they did a 6 Sigma process, we could probably say that pretty much all of them, are 1 out of every 2.3 million or something, would be outside of the control limit. So it's even fewer for the lower bound, half of that. So 1 out of every 4.6 million. So you could find a bag, but it's always outliers. It's always weird stuff. Let's talk about the project for just a little bit here. How's everyone doing, though? A little chill music while we do the project talk. Oh man, I got some good sleep last night. Got to sleep in. Went to bed. Slept in. I have an idea. It's gonna be weird at the start of class. What is something crazy? I get ideas and then I'm like, it'd be fun opening to class. Problem is I can't hear the voice it's gonna make. Let's see. Got a fun idea. Maybe I'll try a different thing. Let's go to the project. First project. Chat tool 1 project. Early bonus. Early bonus. W's in the chat. Okay. We're at 40. Project help. Okay. So we got the project help marked in the chat right here. Don't submit it late. Start early. Get started very early. My grader should be +8. Oh my gosh, that's ridiculous. So here's the thing. The project is worth a good portion of your grade. So I would say you could get the project done this weekend. It's really not that bad. And I think I have a project playlist video right now. But for the project, it's really not that bad. And the projects were 12% of your grade. So I want you to think about this. If you get 108, that's almost a what on your grade. So if you get 108 on the project, that's almost a free what on your grade. Isn't it just all day? Yeah, it's pretty much that. It's pretty much just, it's not posted on the Set2One homepage yet. Oh, it's not? Oh, I think because we're doing it right here. Yeah. The instructions can be found there. Oh, does Terry not have it up? Let me go grab it. Let me see something. I was seeing if Terry was here. So it's not posted. Let's see. I've got it in my inbox. I think this is. I have to like send out a big announcement if we change things. You need to put like a watermark over this and be like, tentative. Text, where's text? Text. Here we go. Where's color? Okay, so we've put this, I put this over here. So can anyone tell me what's the deal with what I'm about to show you? So can anyone tell me kind of what's the deal with this? Anyone know? No one knows? There's no hint on the screen right now? Tentative, okay. All right, there we go. I got that up here now. So it's tentative project. Okay. So now if I say anything and we change it, then 8 a.m. Thursday morning. Okay. 2 seconds. Okay. +8. All right, so all of this is tentative project. Tentative, 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 tentative. So you'll pick one of the data sets right there. You'll take 400. Remember, all this is tentative. So if you're following this, should you follow exactly what's on the screen right now? When you get the project here, should you follow what's on my screen right now? Should you follow what's on my screen right now? Yes or no? No. I mean, it might be exactly the same, but this is tentative. So if you do this and you lose points, I'll put this disclaimer up here. Tentative means tentative. So once again, you're going to start your project by taking a what? What are you going to take at the start of your project, which you've probably done a bunch of times right now? 3 points if you know how to do it. You're going to start the project by taking a what? You start the project by taking a what? Subset, random subset. We love it right there. Random subset for the tentative project. Now, here's the issue. Do not work with anybody on the project. Do not have your computer open next to them. Do not read what they write. Do not follow their format. Do not receive files from anyone. Do not send files from anybody. Do not like, if you're working next to someone on the project, don't look at their screen. Don't ask how to write things. You know, you could say like, just be very careful. Because a lot of times when we talk to people about cheating, they're like, oh, I just worked with them. Well, if your ideas are the exact same, you're copying at that point. So don't be like, yeah, I can talk to you about things, but we can't have our computers open and be writing things down at the same time, or else we're just doing like a team group project. Does that make sense? This is the biggest warning I can give, because we still have some things to file with plagiarism issues, and they take a while. Like, it takes usually an hour just to file one plagiarism case, and then I have to find an hour, file the plagiarism case, do all the follow-up work. It's a lot of work. I don't like doing it. It's not fun, and hopefully these disclaimers stop people. If someone's like, hey, let's sit next to each other with our computers open and look at each other's screens and we're on projects. No! Don't look at each other's screens. Don't tell people what to write. Don't have them phrase things the same thing as you. Because it's very unlikely you should get above the 50% threshold, and don't try to be like, oh, I got 49, I'm good. There's a lot of things that will be similar between projects, but we can tell when there's like really large chunks. And we usually email the students, and then we know what students are going to say. Oh, I worked with so-and-so. It's no coincidence that we find the 2 students a lot of times or 3 or 4. We had a ring of 10 one time where they just sent the project around in a circle. So please, please, please don't do that. So the goal of this project right here is for you to think about how this applies to what you're doing. Frankly, if you take your own data set, graders should be okay with this. Hey, graders, you should be okay with this. You could use pretty much any data here. We're just giving you data to work with that has the data you would need, quantitative and categorical variables, to do analysis. So you've been working with this company for a while right here, and now we get to the meat of it, executive summary. When do you write your executive summary? Who can explain in the chat right now, when do you write your executive summary? When do you write your executive summary? You're looking at probably like a 3 to 4 page report, 4 to 5 maybe. I don't know. It's got the executive summary, it's a page, and then the report's like 3 to 4. At the end, but put it at the start. Great job, Cameron, right there. The executive summary is a summary of your full report that has been made easy to read, no statistical terms. You write it after you've written your full report, and then it's like the front of your report. You could have a cover page, you have a table of contents, and then executive summary at the start, because the point of an executive summary is someone doesn't read your report. It's not an introduction. The executive summary goes over the key tasks of who are we and what are we doing? What did you find out in the data? And what are we going to do? And everything's listed right here. You want to summarize key points, don't copy and paste results. Go through here and talk about the things, give numeric backing. So all this is listed right here in the longer form of what I'm saying, but you write this after you write your report. So you write your whole report, and then you summarize it like a Cliff Notes that gives you everything important, and you put that at the start of your report. So that's super important to do this after you write your report. So you won't be doing executive summary first. One sample Z right here, pick a categorical variable with 2 levels, identify a variable that you are interested in being a success, create a bar chart right here, and using bar charts, so visualizations are going to help with this, making bar charts. How hard is it to make a bar chart, present it, and make it look nice? Who thinks they could do that right now for the project? So make sure your bar chart is in horizontal layout, stack. Bars have values under them, either counts or percentages. Me right there, nice, William. The frequency table should include the counts and the proportions. So make sure to do these things. Dark mode has to be enabled sometimes to see these things. Oh, we have search. We could just put a link to that on there. Or Disco server for assistance. Include a screenshot of the visualization, provide a descriptive write-up. So make sure to have a good write-up for it. Next, create a confidence interval. Anyone know how to create confidence intervals for the proportion? How do you create a confidence interval for the true proportion? Is there maybe a part earlier in this video where you have to create confidence intervals for the true proportion? Is anyone like, oh, wait a minute. Maybe Brian earlier in this video made confidence intervals for the true proportion and walked through how to do them, so that should be pretty easy. Next, describe the 3 conditions, and if they're met, random, 10%, success, failure. So I kind of gave away the answers to those, but make sure to walk someone through them and interpret to the readers what's going on. Interpret to the reader, the interval, what you choose as a success. Look at how these are each different lines. Your answers to these need to be very clear, like what is a success, the thing you are interested in, very important. Next, use 0.5 as the hypothesized value. We're doing hypothesis test today of P0. That's what you're going to test is the true proportion. Without using statistical notation, explain what the null and alternative are. We'll be covering that today. Of a does not equals hypothesis test. Once again, this will be covered today. Finally, using the confidence interval, write the conclusion of the hypothesis test and explain how it assists in the process. So the point of this last part is, what does this mean to us? What are we going to do from this? What are our decision makers from this? So explain the conclusion of your hypothesis test using the p-value, and that'll be very important. One sample t, which means we're doing the mean right here. So t-tests are for the mean. Mr. T is mean. If you do the wrong test, or if you're not a nice person, he'll be mean. If you're doing drugs, he'll be mean too. Pick a quantitative variable you are interested in analyzing, so it has to be quantitative. Make sure it's got the blue on jump. Create a histogram. So we've made lots of histograms before. Put it in horizontal layout with a count axis, that earlier today. Include a screenshot of the visualization, including the summary statistics and quantile section. Provide a short write-up. Don't say things like the mean is, the median is. You need to know how to interpret these values and interpret the center and spread, the shape, the center, and the spread. Does that sound a lot like the visualization projects you did earlier where you have to make a histogram and interpret the shape, center, and spread? Because remember, shape determines the center and spread. If it's skewed, the more skewed it is, the median and IQR should be used. The more normal it is, the mean and standard deviation for center and spread respectively should be used. So that one goes over previous visualization assignments. Next, create a confidence interval, which we did earlier today, 90, 95, or any of your choosing. Include a separate screenshot of the confidence interval for the user. Name the 3 conditions, random, 10%, and nearly normal, and explain how they're met or not met. Interpret to the reader the confidence interval. I am blank % confident that the true blank is contained in the interval blank to blank. Regression. So what do you need to do regression? We're getting near the end of the project. Yeah, that's the end. What do you need to do regression? Which you did regression on a data analytics. What do you need to do regression? What is the first requirement? You will talk about all the requirements, but what's the first requirement to do regression? QQ, straight enough, no outliers, which QQ means 2 quantitative variables. So select another quantitative variable from the one you've already selected and that you suspect may have a linear relationship with the first you chose. Create a scatter plot, which is going to be analyze, fit y by x, identify the direction, form. Ooh, we didn't say strength on there? Well, that's the r squared. The strength, direction, form, unusual features are the 4 ways to describe scatter plots. Clearly note any outliers that may exist in your scatter plot. Something cool you can do that we don't talk about a lot is you can go to jump data. Here, we'll go do this real quick. We'll go to analyze, fit y by x. We need 2 quantitatives. This might just look weird right here. Has a relationship, yeah. So these aren't really outliers. This is a weird plot, but if you click on a point and go right here and go to rows and go to markers, you can put a star on it. If you go to rows and you go to color, you can make it red. Is it easier to see? That was under, we highlighted a point and we went to rows, markers, and rows color. Is it easier to see? I think you can also change the size of it. If you highlight the point again and go to rows and marker, I thought it was there. I thought it was, I thought I could do it. But I thought there was a way to change the size of the points. Maybe they removed that, but there's always neat things you can do in Jump. Right-clicked it, marker size. You have to right-click it, and you have to go here to like, oh, but it does them all. Well, it's easier to see, and you can see that that red star right there is a point I'm trying to call your attention to. It's not really an outlier because this is a weird relationship, but you can mark points. Neat thing to do. So we've got right here, clearly identify any unusual features or outliers that didn't really have had a risk elasticity or plot thickening. Perform a regression analysis to create the residual plot to evaluate the 4th condition. Does the plot thicken? So we go back, we go to this plot, we go to the red arrow, we go to fit line, we go to the second red arrow, we go to plot residuals, and there's the residual plots. We're looking for this one right here. Yeah, it's probably due to a lack of data. Like more data means more scatter, and over here we have sparsity of data, so sparsity of scatter. I don't know. It's not a pretty plot. In your write-up, include the 4 conditions. QQ straight enough, no outliers, plot doesn't thicken. Interpret the slope, the y-intercept, and the r-squared. Also evaluate if the regression model is statistically significant. So my regression model is, the intercept is, I'm going to call that 520 million, which means when Apple Store ID is equal to 0, when file size is equal to 0, we predict Apple Store ID to be equal to 502 million. For each 1 unit increase to file size, we expect Apple Store ID to increase by 54,000 on average. 1.1% of the variation in Apple Store ID is explained by the variation in file size. That r-squared is so low that it's probably not statistically significant, and it's not because the p-value of the slope is not statistically significant. So if you know where to go, and if you have your other data analytics assignments, how hard does this project look? We just did, frankly, today, we did all the stuff in the project because we didn't do tests. We didn't test the proportion, yep. To test a proportion, which is the only thing I didn't show, you have to have proportion output. So here we'll go to, well, the problem is it has too much. I'll use the original data here, rain, no rain. Analyze distribution. So weather, do this, click that. Top arrow here, go to, this is how to test a proportion. To test a proportion, click the second red arrow, test probabilities. It'll have you enter in probabilities to test. You're testing 50%. And we would reject it because 50% is really far away. Well, because I know that mathematically speaking, there's the p-value right there on the test. And we would say that we reject 50% because the p-value is well below 0.05, meaning that we think that 50% is not the true proportion of time that it rains. And thus we have evidence, or does it say use the confidence interval? Let me see, did it say use the confidence interval? I mean, you reject it because it's outside the interval, but you'd reject like success is rain. I know we don't have much time, but you explain B on question 3 on the homework? Yeah, let me look at that. We got enough time. Thank you so much, Jennifer, right there. Let's go do that. Question 3, let's go do that. So good project. Do people feel a little bit better about the project, the tentative project right here? Do people feel maybe a little bit better, like, I got this, it's not gonna be so bad. Not so bad. I'll get it done this weekend, and Brian will give it a quick glance over, and then make over 100 and get some extra points. Good job, William, right there. Homework. And we'll say question 3. Let's go check this out. Thank you for the homework. The homework stays the same. Yeah, I'm so happy towards the end of the semester when people like know how things work. Like, well, because like the homework always stays the same, so you can do that right there. Hey, Jeff, good to see you. Oh, what's up, Jeff? Random guest. We got random guests right here. Jeff, while you're doing this, here I want you to see one of our fun intros, Jeff. And good that you swung by. So here's a random intro as I get the students' next assignment for us to work on. This is one of my favorite intros. So here you go, Jeff. One of our intros, trying to find the one I'm looking for. Here we go, and then we'll work on the assignment. Here we go. Thank you, Evan. We got the assignment almost loaded up right here. I'm loading it in the background, and we'll finish off office hours with that. Question 3, there we go. Little Smash Bros right there, some classic stuff for gamers. Okay, we got the assignment loaded up. Let me remove the tentative project from the screen. We're no longer talking about that. Thanks, Jeff, and we'll definitely talk more. I've got your email. Reach out, and Jeff, I love the video content. I'm going to keep watching and checking it out. So with this right here, we got some assumptions. The housing market has recovered slowly from the economic crisis of 2008. Recently, one large community realtors randomly sampled 29 bids from potential buyers to estimate the average loss in a home value. The samples showed the average loss was 8,161 with a standard deviation of 1202. Now we have a saying here, whenever we get notation.
Notation, brother.
Notation, brother. We gotta mark that notation. So we're going to go right here, go to a new worksheet. We got so much open, tentative project right there, and we're going to mark the notation. So if you know your notation, you're probably going to do all right on the test. That's kind of one of the goals there. So we got right here 29 bids, a mean of this, standard deviation. So we mark the notation to solve out the problem. And now here's one thing I'm going to ask you. If we know n for a one sample t, what do we also know? Who can say it in the chat? If we know n for a one sample t, what do we also know? If we know n for the one sample t, what do we also know? There's a hint coming up right here. If we know n for the one sample t, what do we also know? Degrees of freedom, great job, William, right there. N is equal to 29, so degrees of freedom, which is n minus 1, that really complicated formula, is going to be 28, which tells us which t we are using. So the T is going to be found via the T app. MuBot's already put it in the chat right there because MuBot is always helping us out. So we're going to click the app and go over here with our 28 degrees of freedom and grab that T statistic. So go over to the T app. Student T looks like the normal, looks even more like the normal when we have 28 degrees of freedom. We'll find out what % confidence they want us to build, and I usually like to carry these to 4 decimals just in case. So what do they want us to do with this information? Well, let's go find out. So with assumptions, how are we going to do this? The data is assumed to be independent and from a normal. Check the assumption with the randomization condition. Check the normal population with the nearly normal using a histogram. That sounds right. I'm not doing sampling distribution. They assume to be independent and from normal. Check the assumption. Check the independence with the known. Don't check the independence with nearly normal. And then success failure. Why are we not doing success failure? So who can explain why we are not doing success failure? Who can explain why we are not doing success failure? Oh, there, Jennifer's already got it figured out. Great job, Jennifer. Let's throw some points in the chat. Jeff, and I'm gonna go out on a limb here, make Jeff a standard mod. Jeff, you're one of our honorary mods right here. Just don't put everyone in timeout. Please don't. Making Jeff an honorary mod on the channel. We got a lot of honorary mods and friends of the channel who swing by and say hey. So with this right here, you're right, because we're not doing true proportion. The proportion is when we check success failure. Nearly normal is for quantitative data. The average loss is going to be quantitative. And so Jennifer has figured it out right there, that the T statistic and the T I need is going to be close to 2.61 or so. I'm guessing 2.61. Because it says 99% confidence. So when you go over here to 99% confidence, no, it's 20, how many degrees of freedom? 27? I said 2.71, right, with my guess? got 20. Let's get even closer. 2.76. And that's to 2 decimals. We grab this right here, 2.7633. And we bring it back over here. We drop it into the equation once we get the equation back on the screen. And the equation's going to be 2.7633 s over square root of n. Square root of n is going to be square root of 29. Standard deviation is 1202. The mean from the sample was 8161. Once again, we need to know this is the margin of error. This is the standard error. This is the t that denotes confidence. And last but not least, this is the estimate of the truth right there. So make sure you know your components of a confidence interval and what goes into it. The standard error is s over square root of n. The t is relative to level of confidence. The two quantities multiplied together make the margin of error. And the estimate over here is your best guess given from the sample. So solving out the mathematics will obtain the answer for us. And we take 29 square root it. And there we go right there. Invalid input. What'd I do? 29 square rooted again, copy it. 1202 divided by times 2.7633. There we go right there. That is the margin of error. 616, 8161. That's interesting. And so 8161 plus this, there it is, 877, round to the nearest whole number as needed. 8778, hopefully we get it right. No math errors today. And then minus, because minusing it brings you back down to the center. But we're just taking the center and minusing the margin of error off of it, 7544, and that rounds to that, 7544. Did we get it right? Cross your fingers, round to the nearest whole number as needed. Check answer. I am 95%. Oh, we didn't even interpret it. I am 90% confident. No, 99. I am 99% confident that the true loss in the housing market crash is contained in the interval, whatever that interval was. Does that make sense, Jennifer? And great work, Jennifer. We'll throw out some last few points right here. But does that make sense right now that I am 99% confident that the true loss that was seen in the housing market crash in 2008 is contained in the interval blank to blank? Or if you're talking to normal people, like people who don't do stats, you'd be like, probably people lost on average somewhere between this and this. Like, that's my best guess. Like, somewhere between this and this. We don't usually do the I am blank percent confident. But then someone says, well, how confident are you? I got 99% confidence because that's what I created the interval using. With that, we're going to head out. Bye for now, everyone. Bye.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!